Very good morning to one and all.
My name is Yokrishna. Today I am going to start manufacturing process. Introduction to casting process from second B.Tech mechanical. Casting process. So what is casting process? Casting is a process used to making components of complemented shapes in larger quantity. Metal casting is another definition is the metal casting is a process of forming metallic objects by melting point or objects by molting metal pouring into the mold cavity to get a required shape by using solidification is called a casting process. Producing a metal parts by pouring molten metal into mold cavity to required shapes to allowing the metal to solidify. When solidified the desired metal, when solidifying the desired metal objects is taken out from the mold either by breaking into mold or taking the mold apart. The solidified metal piece is called a casting. The plant when the casting is made is called foundering. The process is also called as foundering. Steps involved in casting process. There are 11 steps involved in casting process. First one is make the pattern out of wood or metal or plastic. Prepare the necessary sand mixture for mold and core making. Prepare the mold and necessary cores. Melt the metal or alloy to a cast. Pour the molten metal or alloy into a mold and remove the casting from the mold after the metal solidifies. Clear and finish the casting. Test and inspect the casting. Inspect the casting. Remove the defects, if any. Reliable the casting stresses by heat treatment. Again, inspect the casting. The casting is ready for shipping. So these are all the steps involved in casting process. Next, metallurgy involved in casting process. So we can see the diagram. So what is the metallurgy in casting process? So first of all, we can take pattern making or core making gated system to the molding. In sand and mold, in mixture to the pouring under sand. Then it come to melting of sand by using furnace. Pouring into mold by solidification. So casting, then go to casting, shake out removal of risers apart and gates. Next, then go to heat treatment. In then heat treatment completed and going to cleaning and finishing or additional heat treatment. Next, inspection. So we can inspect the defects, pressure tightness, dimensions, etc. So first we can choose the molding. Make the pattern of desired shape and size out of the wood, metal or plastic. Take the sand mixture according to the type of casting for mold and core making. Making cores for the purpose to support the molding. Prepare the mold cavity with the help of patterns and cores. melt the required metals or alloy, pouring the molten metal into the mold cavity and made the molten metal to solidify. Next, removing the solidified metal alloy from the mold cavity. Clean the finishing the casting. Applying heat treatment for removing the stresses in the casting. Finally, we have test and inspect the casting. So these are all the methods involved in casting process. Next, what is pattern? Pattern preliminary used to produce a mold cavity into sand. It is slightly larger than desired casting due to various allowances. So pattern, it is a form of pattern is the foundry melt form. It is basically defined as a molten metal of any object to constructed that it many used to forming on impression called mold cavity. Pattern making is between that what is done within the foundries and that is done by separate business called the pattern shop. A pattern is defined as a model of casting constructed in such a way that it can be used for forming and inspection. Next, types of patterns. So types of patterns one by one you can discuss it later. So first we can, what is the types of patterns? First, solid or single piece pattern, split pattern. So single piece pattern, split pattern, loose piece pattern, match plate pattern, gated pattern, weave pattern, skeleton pattern, segmental pattern, multi-piece pattern, scope or drag pattern. So we can discuss in one by one. So first, solid or single piece pattern. A pattern which is made without any loose piece is called a single piece pattern. So we can see the diagram. So it is the simplest pattern made by one piece. It is cheapest pattern also. So applications of solid single piece pattern is oil tamper, stuffing box, glanted or steam engine, glanted of steam engine. So these are all the applications of single piece pattern. So next, split pattern. In most of the foundry applications, many patterns cannot be made in single piece because of the differential difficulties encountered in mounting them. One part is located in the lower half mold and another part is upper half. So we can see the diagram. So pattern is split into two pieces. So one part is scope, another part is drag. So easily withdraw pattern. So applications of pattern is spindles, stream walls, so AK-47 refill stock. Next, multi-piece pattern. Pattern is split into more than two objects. So in this pattern consists more than two pieces to produce easy making or easy molding. Then it is called multi-piece pattern. Number of man or task may require to make a mold will be equal to number of pieces in the pattern. So we can create number of pieces by using application means lap joint, dove joint, meter joint. So we can see the figure. Top is cope box and bottom is drop box. In drop box we can mix the melting sand. So middle of this check box. Facilitate on easily mold and withdraw patterns. Pattern may consist of 3 or 4 or more numbers. Depends on the patterns. We can use the multi-piece pattern. So next type, loose piece pattern. In some instances is a molding process, depends upon complexity of the part. The pattern cannot be made in one piece as there will be a undercut. To overcome its difficulty, some patterns are produced in loose piece pattern. In pattern consists of loose piece for easy to withdraw. So you can see the figure also. We can solid piece in upper part is lower loose piece pattern. This loose piece from internal part of pattern during molding. After molding is completed, pattern is withdrawn, leaving the loose pieces. So applications of pattern is rotor hub, axial pin, handling parts. Next, cope and drag pattern. Cope and drag plates consist representing the cope and drag parts. The pattern having the two boxes. It involves both mold the different boxes. After completion of the mold, two boxes are assembled to make the cavity. So it is also called as two-piece pattern or single-piece split pattern. So we can see the diagram. So top figure is cope blocks, cope pattern, bottom is drop pattern. This is the runner pattern. We can pour the metal by using runner. So this is the gating system. When runner through the gate passing through gating system also, we can complete the pattern. So applications is flange pipe, water jacket of JCB head, hose pipe, coupling head. Next, match plate pattern. When small casting are to be produced in large quantity, a match plate pattern is used. On one side of match plate is cope plate is prepared and another is drag flask. Two parts of the flask are ready to match plates in withdraw and both parts simultaneously used to got the required mold cavity. So by using match plate pattern, so we can see the diagram match plate and pattern match plate. So patterns are made in two pieces. One piece mounted on one side and another piece of the plate called match plate. Plate may carry one or group patterns mounted on match plate. Produce accurate casting at fast rates. So applications generally used for small casting such as piston rings of IC engines and rotor hubs. Next, gated pattern. In this pattern are usually made of metals. This consists of loose piece pattern with attached gates and runners to provide a channel. through which the molten metal to the bed. This facilitates uniform gating system and avoid manual preparation of gates in the mold. Can be produced in many castings at one time and hence save time as well as cost. So applications of gated pattern used for small castings such as corner bracket. Sweep pattern. It is generally used to prepare large symmetrical casting. It is made of wooden board and it is sweep the sand in casting shapes all around the circumference. It is used to production of large circular sections and symmetrical shapes. Axis symmetrical molds, particularly large in size, some shapes may be means of sweep patterns. So applications of sweep pattern is symmetrical shapes such as wheels, rims, large of cast irons and bells shapes, etc. So next, skeleton pattern. Skeleton pattern. So pattern is the skeleton is a desired shape, generally mold the metal base, molded on the metal base. The pattern is a skeleton or desired shape, generally molded on the metal base. Skeleton is made from wooden strip, is filled with loam sand and rammed. Extra sand is removed by trickle. For every large casting, solid patterns would require a amount of timber which may not be economical. Cores are required in if necessary. Applications of large casting is very economical as less material cost. A strike off board is known as stricle board is used to remove excess sand out from the space around the ribs. Core is necessary can be produced separately. So applications is large castings such as turbines, water pipes, L-bends, etc. Next, segmental pattern. A segmental pattern resembles a sweep pattern in the sense that for getting required shape both simplify a part or portion of the pattern and not fill or compound pattern. Both segmental and sweep pattern generate circular shape. A segmental pattern differs from the sweep pattern in the sense that it does not require continuity. It completes one portion of the mold and then moves to the next portion to make the next part of the mold and so on. It is mold is completed. So we can see the diagram. So two horizontal is arms, a pivot or spindle is bottom of the arm, segmental patterns by using fixing the green sand. Next, follow board pattern. It is a wooden board used to support during the mold, acts like a base for pattern. Follow board are used to this pattern which has odd shapes. It supports weak patterns or also acts like natural pattern line. Applications, it is used for casting master pattern from for many applications. Next, what is pattern materials? So wood, metal, plaster, plastic, wax. So these are all the plastic pattern materials. So in wood, we can choose teak, mahogany, white pine. In metal, we can choose cast iron, brass, aluminum, white metal. So in this figure, we can see the images of the metals. So wood, metal, plastic, pattern materials, plastics, plaster, wax, etc. So the pattern material should be easily worked, shape and joint. So it is light in weight. So this is strong, hardened or durable. This is resistance to wear and absorption, resistance to corrosion and chemical reactions. The dimensionally stable and unaffected by various in temperatures and humidity. So it available at low cost. So color scheme of pattern. So we can choose the colors of the pattern. So surface it cast when casting is processing. So what is the color? Is black. So machine surface when surface machining the surface for the casting is red color. Core prints and seeds yellow. Loose pieces yellow or red. Diagonal strip. Stop off yellow or black. Diagonal strip. Next, last and final, selection of pattern materials. So require a good pattern. So what is the selection of the pattern? So require the good pattern. So secure the desired shape and size of the casting. Cheap and reliability, readily repairable. Cheap and readily repairable. Simple in design for case of manufacturing. Light in mass and convenient to handle. Have high strength and long life in order to make as many mounts as required. Retain its dimensions and rigidity during the definite service life. Retain its dimensions and rigidity during the definite service life. So these are all the selection of good pattern materials. So thank you.